guys, welcome to my YouTube channel. Today we are going to be talking about a fundamental concept in Rust known as stack and heaps. These concepts are often overlooked in other programming languages, in most programming languages, but in languages like system programming languages like Rust and the rest of them, they are a very important concept that affects decisions we make as software engineers or developers. In actual terms, stacks and heaps are portions in memory that our code uses at runtime, but they have distinctive features and we are going to look at them next. So let's start with stacks. The stacks operate on a last in, first out basis, much like a stack of books. So let's say, for instance, I have this book and this is the last one, or let's say this is the first one. I add another one at the top and I add another one at the top. Whenever I want to get one out of this, I take it out from here. I take this out of here and just like that. And this is how like the stacks operates. So it works on a last in, first out basis. So this is analogous to pushing data into a stack and popping data out of the stack. Crucially, all data on the stack must have a known and a fixed size. Now let's contrast the stack with the heap. When you allocate space on the heap, you allocate a certain amount of memory. The allocator finds a certain spot in the memory, marks it as something that is in use, and returns the location to that spot. Unlike the stack, sizes on the heap can have unknown or dynamic changing sizes. Pushing to the stack is faster because the position of new data is always at the top of the stack. Meanwhile, when it comes to the heap, it involves a lot of work because the allocator has to look for available space and also perform bookkeeping in order to mark that that particular space has been allocated to a particular data. So accessing data on the heap is slower because you have to follow the pointer that refers to the actual data, whereas accessing data on the stack is faster because the data are all close together, and it has been noted that processors are able to find data that are like close together as it is in the case of data that are found or allocated or data that are on the stack. When you call functions in your code, the values passed into the functions, including the pointers that are pointing to actual data on the heap, as well as the local variables of that function, are all stored on the stack. And when the function has been executed or it has concluded, all these are being popped off the stack. Now, as we venture into the world of Rust ownership system, keep in mind that managing data on the heap, avoiding duplications, as well as cleaning off used data are issues that are addressed by the Rust ownership system. Once you grasp ownership in Rust, you won't have to constantly think about the heap and the stack. You would now have to understand that the design behind the Rust ownership system was mainly built or made that way to manage heap data. Thank you guys for joining me in this video, though it was a short one. Stay tuned with me as we explore the amazing world of ownership in Rust, where we'll be looking into more details about the ownership system and the reasons why the people behind Rust decided to go with this route in managing data that are stored on the stack and the heap. Thank you so much for joining me once again, and I'll see you in the next one. Peace. Bye.